everyone. Good afternoon, all. How are you? Okay.
21 JD वाले student है ना?
Technical course.
21 JD.
So let me start off whether my voice is clear. Start the topic that is inequality. What is the name of the topic? Inequality. So
Good afternoon. We will be beginning the session in let's till then, can you whether I am audible and visible or not? Hello students, there is some technical issue, that is why I'm not able to download, switch on this Zoom. I was not able to switch on the Zoom link. I'll be starting in 1 minute. I'm trying to resolve this. Please wait and thank you for your patience. So I am sharing my screen now. We will begin our session. So can you guys let me know if I am audible and visible or not? I cannot see even a single message in the chat box. I think you guys are allowed to send the message. Hello, hello, hello. Hello, hello. Yeah, hello. Yeah, so today we will be studying about hyperbola. So today's session will be about hyperbola. Hyperbola is a type of conics, just like circle, pair of straight line, ellipse, and parabola. So just things, hyperbola is also a pair, part of a conic section. So let's understand what do we mean by hyperbola in mathematics. So for today, we will be studying all about these topics. First of all, we will be looking after the definition, and then we will be trying to trace the hyperbola. Then we will be finding the conjugate hyperbola. Then we will try to represent it in parametric form, the equation of like the coordinates of hyperbola, position of a point with respect to hyperbola, line and hyperbola, equation of tangent to hyperbola. Right, so these are the points that we will be covering today. Yes. So let's move on to the next slide and start our session. So let's try to understand the definition of hyperbola. So like we know, every conic section is defined in terms of the locus of a point, like the distance of the point from a fixed point and a fixed line. So this fixed line is called as directrix, and that fixed point is called as focus. So a hyperbola is defined as the locus of a point moving in a plane in such a way that the ratio of its distance from a fixed point to that from a fixed line is a fixed constant which is greater than 1. Okay, so the thing is, here you can see that this is a fixed line, this is the fixed line that the definition is talking about, and this is the fixed point, right? And this is the point which is moving. This point P is moving, and this point P is moving in such a way that the ratio of its distance from a fixed point, that is focus, and ratio of its distance from a fixed point to the ratio of its distance from the fixed line is always a fixed constant which is greater than 1. So for ellipse, if you remember, for ellipse, eccentricity used to come, eccentricity was always less than 1, correct? So I think you guys know what eccentricity, like the meaning of eccentricity is now. So eccentricity is the definition of eccentricity is the ratio of the distance of the ratio of the distance of a point from a fixed point to that of the fixed line. Correct? So this is what eccentricity is all about. So we know that the definition of hyperbola is like this, and in this scenario, the ratio comes out to be greater than 1. So only difference is in ellipse it was less than 1, in hyperbola greater than 1. Now you can see this diagram of hyperbola. So this the part that I am shading here with orange marker, reddish marker. So this diagram is hyperbola. This is a hyperbola. This is a hyperbola. So these both hyperbolas, like you will figure that these are the two hyperbolas, but no, this is like this diagram or this hyperbola represents one equation, right? So we will be finding out how the equation of hyperbola looks like. So the hyperbola, in hyperbola also, if you guys remember that then the focus in ellipse was a comma 0 and minus a comma 0. So it is the same scenario in hyperbola as well. And this line here, it is called as latus rectum. So we all remember the definition of latus rectum, which will never change in any of the conic section. And the definition of latus rectum is the line perpendicular to the axis and passing through the focus. So there were two focus in ellipse, so we could draw two latus rectum. There are two focus in hyperbola, so you can draw. So this is a latus rectum, this is a latus rectum. So there are like two latus rectum in hyperbola. Similarly, since there are two focus, so there will be two directrix. So this is a directrix, this is a directrix. So the equation of the directrix is also similar to what it was in ellipse. So if you study ellipse in a very nice manner, then you will be very good at hyperbola also, or vice versa. So now we remember that the equation of directrix is x equals to minus a by e, right? Now now here so the equation of hyperbola is represented by this particular thing, x square by a square minus y square by b square equals to 1, or x square by a square minus y square by b square equals to minus 1. So these both are represented, like these both equation represent our hyperbola. Now for the hyperbola also, you consider the hyperbola that was shown in the previous diagram. So this is the center, right? So the center, this center is the point of coincidence of x-axis and y-axis. So this is 0 comma 0. So hence 0 comma 0 and 0 comma 0 is the center. So in hyperbola, like in the ellipse, it was for ellipse. If you guys remember, for ellipse, the axes were named as major axis and minor axis. Though the namings are not very important, but since these are fundamentals, let's understand In hyperbola, these axes are named as transverse axis and conjugate axis. So for this thing, see, so this diagram is represented by this equation, and this hyperbola is represented by this equation. So these two are different hyperbolas, but both are the standard form of hyperbola. So in this hyperbola, this is like a comma 0, and this point is also, sorry, this is minus a comma 0, this is a comma 0. So this is called as length of transverse axis. So this is transverse axis, and it comes out to be 2a, right? So this is a comma 0, this is a comma 0. So the length of transverse axis comes out to be 2a. Similarly, in this thing, length of transverse axis comes out to be, this will be 0 comma b, and this will be 0 comma minus b. So length of transverse axis will come out to be minus, sorry, the length of transverse axis will come out to be 2b, and the length of conjugate axis is here 2b, and here it is 2a. So these things are just to remember. Focus we already discussed, it is similar, plus minus a comma 0, and since x, y, and a, b have interchanged, this will become 0 comma plus minus be. uh, Again, for equation of directrix, this is x equals to plus minus a by e. There x is changed by y, and a is interchanged by b, hence y will become, y equals to plus minus b by e will become our directrix equation. For this particular thing, eccentricity is defined as, since we want a value greater than 1, so you can always see that a square plus b square, numerator is always greater than denominator. But in this case, where where the hyperbola is of this form, you should remember that the denominator is represented by a square, and when the hyperbola is of this form, the denominator is represented by b square. In both the cases, you can see numerator is greater than denominator, hence eccentricity will be greater than equal to, sorry, not equal to, it will be greater than 1. Now the length of the lattice rectum. So you guys want to calculate the length of the lattice rectum. Now you can see here, to find the length of the lattice rectum, see, I am doing the rough work here. X square by a square minus y square by b square equals to 1, right? And we all know that the lattice rectum always passes through the point a or minus a comma 0, right? This is a comma 0, or this is minus a comma 0. So x coordinate, we know the x coordinate of the lattice rectum, which is ae, right? So I'll put, substitute a square e square. Similarly, we did this thing in ellipse also. This will become y square by b square. Now this becomes 1, a square gets cancelled. You will get 1 minus e square into b square equals to y square. Now we know e square is a square, e square is a square plus b square upon a square equals in, and this will become into b square equals to y square, right? So what this becomes is, this becomes a square minus a square minus b square by a square into b square equals to minus y square, So now this becomes b power 4 upon a square equals to y square. So y comes out to be plus minus b square by a. So hence we know the y coordinates now. This is plus b square by a, this is minus b square by a. So this length is 2 times of b square by a. Hence the length of the lattice rectum is 2 times of b square by a. And here, since we know that x is changed by y and a is changed by b, so this becomes 2a square by b. Now find the equation of the hyperbola whose directrix is 2x plus y equals to 1, and focus is 1 comma 2, and eccentricity is, what is the value of eccentricity? Root 3. So we all know that PS by PM is equals to E, right? So this is how you find the equation. So PS, let the point P which is moving, for which we have to find the equation. Let's say that it is h comma k, right? So what we will do here is, first of all, the distance of h comma k from the focus, which is PS. This will be h minus 1 whole square plus y minus y minus 2 whole square. So this is the under root of this is the distance of this point P and this S, focus S. Now this distance is equals to E times of this distance is equals to E times of the distance of this H comma K from this particular line. So this line, the distance of this line is mod of 2x plus 2x plus, sorry, 2h. The distance of that point H comma K from the line is given by 2h plus K minus 1 upon under root of 2 square plus 1 square, right? Now this, if you square both the sides, this becomes h minus 1 whole square plus y minus 2 whole square is equals to e square upon this is 5, and this becomes 2h plus k minus 1 whole square, right? So you can simplify this, you will get 5 times of h minus 1 whole square plus y minus 2 whole square equals to e square is 3 times of 2h plus k minus 1 whole square. So we can further simplify this, and but generally this equation will be like this. So this is the equation of hyperbola that has been asked to us. So you guys can see here the same thing has been done, right? So right, 3 by 5, 2 times of plus y minus 1 whole square. Here just that we have taken h comma k in place of x comma y, h comma k in place of h comma y. So if you want to find out, let's also like finish this calculation. 5 times this is h square plus 1 minus 2h. This is 5 times y square plus 4 minus 4y is equals to 3 times of a square plus b square plus c square plus 2ab plus 2bc plus 2ac, right? So let's this becomes 5h square minus 10h plus 5 plus 5y square minus 20y plus 20 equals to, this becomes 12h square plus 3k square plus 3 plus 12hk minus 6k minus 12h. Now bring that h square here, it becomes 7h square plus, sorry, 7h square minus 2 k square, this is k, this is k, sorry, this is k, 2k square, the term 6k he is here, it is 20k minus 20k, like plus 20k, this becomes 14k minus 10h here, it is minus 12h, it becomes minus 2h plus 25 here, it is plus 3 here. So plus 12hk will remain as it is. 25 will go there. It will become minus 22 equals to 0. So after substituting x comma y in place of h comma k, the equation will be what? Let's write it down here. 7x square minus 2y square plus 14y minus 2x plus 12xy minus 22 equals to 0. Let's check whether this equation is true. See, it is the same that we got over here. So this is our required hyperbola. Let's solve another concept question. This is like concept test. So if the foci of a hyperbola are foci of the ellipse, if the eccentricity of the hyperbola be 2, then its equation be what? So try to solve this question. So now this is like a square is 25, b square is 9, so a is 5, b is 3. So here we can find out the eccentricity of this ellipse. eccentricity is 1 minus b square by a square ka root, which will come out to be root of 1 minus b square is 9 upon 25. This comes out to 4 by 5. So eccentricity value is 4 by 5 for the ellipse that has been given to us. So the focus will be plus minus 5 e comma 0. So this will come out to be plus minus 4 comma 0. So it is saying this is the focus of the hyperbola. This is the focus of the hyperbola as well, right? So the focus of hyperbola is plus minus 4 comma 0. So focus of hyperbola is also plus minus a e comma 0. So this a, let's say this is a1. Okay, we will write capital A for hyperbola. So this will become capital AE plus minus comma 0. So capital AE, value of capital AE is 4, and here E is given as 2. So capital A is 4 upon E, which is 4 by 2. So we get 2. Now we have to find capital B so that we can find the equation of hyperbola. So we already know that E square is equals to under root of A square plus B square upon A square, right? So what I will do here is I will write under root of A square, capital A square is 4 plus B square is B square upon A square is 4. So this value is equal to E square, and E square is also 4, right? So what will this become? Sorry. E is this. So E square is E is 2 here. So this is 2 under root of 4 plus B square upon 2. So we get 4 plus B square under root is 4. So 4 plus B square is 16. B square is 12, right? So we know that value of B square is, sorry, capital B. We are taking capital B for hyperbola, since A and B we have taken for ellipse, right? Capital A and capital B. So B square we got 12, we got A value as 2, so A square is 4. So equation of hyperbola can be written as x square by a square, which is 4, minus y square by b square, which is 12, equals to 1, right? So this will be the equation of hyperbola. So this is what we got, right? Correct. So let's solve another question. The problem here is if 5x plus 9 equals to 0 is the directrix of the hyperbola, then its corresponding focus is what? So first of all, x is equals to minus 9 by 5 is the directrix. The hyperbola is given by x square upon 9 minus y square upon 16 equals to 1. Right here, a square is 9 and b square is 16. So eccentricity of the ellipse is a square plus b square upon a square, right? So this comes out to be a square is 16 plus 9 upon a square is 9. So eccentricity comes out to be 5 by 3. So we know that x equals to plus minus a by e will be the directrix of hyperbola. So plus, sorry, so minus a by e, let's say minus a by e is minus 9 by 5. We know that e is positive, a is positive, so this minus sign will be this minus sign, so it gets cancelled. We know the value of e, right? A is equals to 9 by 5 into e, so a comes out to be, oh, we can already find the corresponding focus, its corresponding focus. So the corresponding focus, first of all, we know that this is the hyperbola. So this is the directrix over here, and corresponding, since the directrix here is given and the x is negative, so it will be, the focus will be minus a comma 0. So minus a comma 0 will be equals to minus of a is given by 3 into 5 by 3. So focus is minus 5 comma 0. right? So focus is minus 5 comma 0. So here minus 5 comma 0, correct? This was asked in JE 2019. Now conjugate parabola. So, so what is the difference between conjugate parabola and the parabola? So see, the conjugate meaning by like basically conjugate meaning in general is this minus sign. Sorry. First of all, we know that we have studied in complex number that a plus ib conjugate is a minus ib, right? So this sign changes, the real one sign. Here what happens in this conjugate also, there is a sign change, but there is like unique form of sign change. This becomes x square by x square minus y square by b square equals to minus 1. This 1 becomes as minus 1. So this conjugate hyperbolas. So now these hyperbolas are conjugate to each other. So as you can see here, this thing is simply represented like this. This minus 1 was taken here. So if you take this minus 1 over here, the equation of conjugate hyperbola will become y square by b square minus x square by a square equals to 1, right? So this is the equation of conjugate hyperbola. Now in the previous one we already studied that e square in this hyperbola, e square is under root of, sorry, e square is a square plus b square by a square. In this e square will be a square plus b square upon b square, right? So this is the difference. You can see here the length of the lattice rectum in this lattice rectum was 2b square by a. In this lattice rectum will be 2a square by b. So we have to remember that in conjugate, this is a trick method. This is a trick method. In conjugate, you can like change x to y, you know, interchange. You know, I write the word interchange. Wherever you see x, you change it to y, and wherever you see a, you change it to b, and vice versa. Right? This interchange. So you get the conjugate. So that is why here a was changed to b and b was changed to a. Here also you can see a was changed to b, b was changed to a, and again a was changed to b. So you get exactly the same thing. Now let's solve a question. Find the length of the transfer axis and conjugate axis, eccentricity, coordinate of the foci, vertices, length of the lattice rectum, and equation of the directrices of the. So these are all the basic things that we are supposed to do. So let's do it once for like practice. So the equation of hyperbola divided by 144 throughout. So it becomes x square by 9 minus y square by x square by 9 minus y square by what, 16 equals to minus 1. So here again, here a is 3, b is 4. Now length of transverse axis. So you guys, if you don't remember, let's check what was the length of, see, length of the transverse axis in the conjugate parabola hyperbola was 2b. Okay, so here also length of transverse axis will be 2b, length of conjugate axis will be 2a. So 2b will be equals to 8, 2a will be equals to 6. Eccentricity will be equals to under root of a square plus b square upon b square. This time we have to remember that the denominator will be b square over here. So a square is given as 9 plus 16 upon b square is 16 again. So this becomes 25 by 16. Becomes 5 by 4. So eccentricity comes out to be 5 by 4. Coordinates of the foci. Coordinates of the foci. Earlier it was x equals to plus minus ae. For conjugate it is we have to change x to y and a to b. So it will be y equals to plus minus, sorry, earlier it was plus minus a comma 0 in normal hyperbola, and in conjugate hyperbola it will be x will change to y, so 0 will come here, and a will change to b, so it will become 0 plus minus b. So this will be 0 plus minus b value is 4 into 5 by 4. 4 gets cancelled, 0 plus minus 0 comma plus minus 5. So this is our foci, coordinate of the foci. Vertices is like 0 comma b, 0 comma minus b. So vertices will be 0 comma plus minus 5. Now, sorry, 0 comma plus minus 4. B is 4. Now, length of the lattice rectum will be 2. Earlier it was 2a square by b in conjugate, 2b square by a, in conjugate it is 2a square by b. So lattice rectum will be 2a square by b. 2a square will be 2 into a square is 9 upon b. B is 4. 2a square by b, this comes out to be 18 by 4, and which is 9 by 2, right? So this is 9 by 2, 4.5 for better understanding. Now equation of the directrices in that hyperbola was x equals to plus minus a by e. Now it is y equals to plus minus b by e. So equation of the directrix will be, what will be the equation of directrix? Plus minus, what is the value of b? B is 4 upon, what is the value of e? E value is 5 by 4. So this becomes plus minus 16 by 5. So this is y equals to plus minus 15 by 5 is equation of directrices. So you can see it is 8, 6, which we found out. Eccentricity was 5 by 4, which was correct for us. Foci we got right, we got vertices right, we got length of the lattice rectum right, we got equation of the directrix also right. So our approach was correct for conjugate hyperbola. So now here let's solve one question before ending our session. The eccentricity of conjugate hyperbola to the hyperbola, this is what? So first of all, this equation of hyperbola is x square upon 1 minus y square upon 1 by 3 equals to 1. So the conjugate hyperbola will be x square upon 1 minus y square upon 1 by 3 equals to minus 1. So eccentricity to this hyperbola will be E equals to under root a square plus b square upon b square. So this will come out to be 4 by 3 upon 1 by 3 under root. So this will come out to be 2. So the eccentricity of the conjugate hyperbola will be 2. Thank you guys for the session. We will solve and we will do other questions in the next class. Have a good day.